Hi, we're Team FPGBC. I'm Kostas Akrovoulos.
Mike Gardner.
And I'm Arjuna Hayes.
And we're designing a Game Boy Color for an FPGA.
The Game Boy Color is a highly successful handheld console made in the late 1990s. We view this as an interesting project because the Game Boy Color has yet to see a successful completion in 18545. It's also a console which is challenging enough for a semester project, yet flexible enough for future feature work. Finally, the Game Boy Color holds a special place in our childhood and those of our generation.
Our three main goals are correctness, completeness, and compatibility. We want to make sure the games are correct and accurate as possible as far as video and audio is concerned. For completeness, we want to get as many of the components done of the Game Boy Color as we can. And for compatibility, we want to make sure it's compatible with as many Game Boy Color games and hopefully Game Boy games as possible. The main components as listed here are the CPU, the PPU, the APU, memory, a cartridge reader, and the SNES controller. For the CPU, or Central Processing Unit, the Game Boy Color has a custom Zilog Z80 processor. It's very similar to the original Z80, except that it has a couple of extra bit shifting instructions and a few additional addressing modes. In our research, we found the TV80, which is a Verilog implementation of the original Zilog Z80. We are intending to use this because it's open source. We're intending to use this CPU and then integrate the extra bit shifting instructions and addressing modes necessary to make the GBC run.
The Pixel Processing Unit consists of an LCD controller and video RAM. The video RAM contains a frame buffer as well as registers for scrolling and positioning the screen. Additionally, the PPU manages and layers sprites, background maps, and tiling graphics. Most of our sources for documentation comes from Pandocs, which is the definitive documentation for the Game Boy and Game Boy Color. The documentation lists the important address ranges pertaining to graphics processing. Unlike the CPU, we will not be building off of a pre-existing solution. The PPU will be made from scratch by a crack team of developers.
The Game Boy Color has no audio processing unit. All the audio processing was done by the CPU. The only separate audio device that the Game Boy had was an amplifier. So we do in fact need an audio interface because we need to convert the Game Boy's sound data to something compatible with our audio drivers. So we'll do a little bit more research after the audio lab and find out how viable this solution is.
For our main memory, we will be using the block RAM of the FPGA. We will also need to write a DMA controller to interface between the PPU and the block RAM, required for transferring sprites and other graphics objects.
The Game Boy Color cartridge reader is a 32-bit input device that we will use to access the memory within a game cartridge, allowing us to play any Game Boy Color game. To acquire said reader, we plan to strip one from the back of a working Game Boy Color. The SNES controller will be the input device used for the actual gameplay of a designed Game Boy Color. It was chosen for its similar layout to the Game Boy Color controls, and it also provides some extra buttons for debugging and added features. We are prioritizing the CPU, PPU, memory, and cartridge reader to be vital to reaching our project goals, whereas we consider the APU to be a non-vital element. Having said that, if we reach a time constraint toward the end of our project, the APU will be dropped as a backup plan. If we realize a larger, non-time related design problem, we will be switching to the Game Boy due to its design similarities to the Game Boy Color and the fact that a previous group has done the same switch.